Hello everyone, here's Manuel and welcome back to a new update, a new video about some updates of the Bodynodes project. So today we want to talk about a new functionality, new algorithm that we have made. It's called steady feet, and it basically let us keep a character steady on his feet, as the name says, right? Now this is very important. If you were to come from a traditional way of animating a character, this doesn't really sound right, because you would just have to move bones in such a way, or the armature in such a way that, you know, the feet are steady, stay there. So why do you need how can you create an algorithm? The thing is that in the Bodynodes project applied in Blender, we are in a very different situation. And the situation is that we already have animation data, which usually is very raw. It comes directly from our own movement, because we have body sensors on us that are tracking our movement, and this data is collected, this motion data is collected and then sent to the character in Blender directly. So what happens is that due to different problematics, the characters will move very realistically, but not as we expect it to move or to react in the environment. So let me show you exactly what I mean by that. So this is the animation that I took some time ago. So what's the problem here? First of all, the animation stick all around here on the hips. It doesn't move from there. First problem. Second problem is that the feet, you see, they're not stick on the floor, and they actually move in sort of different way. The animation of the feet, they're not really moving together. You can see that the right foot is sort of moving a little bit backwards respect the left foot. Yeah, you can kind of see. So we would like to have actually something that does it for us. We don't really want to reanimate a character. We have already animation data. We just want to kind of make the tool figure it out by itself what it has to do. And that's what we did. That's what we have been working on. Before going in there or showing you what happens, I would like to show, just to give a small alert in here. The thing is that in order to create this functionality, we had to do some changes in the armature. Now, I'm just gonna say that you probably don't have to worry about it, but if you ever wants to use our code, our project in yours, please start to use it from the most recent version, because otherwise, if you have the bones structure in different way, you won't be able to use this functionality. And what do I mean by that is that before, that's what, okay, this is the same armature but in edit mode, so you will see what is the original positioning. You see the bones are all, or the legs, the bones of the legs are all connected with each other. Before, they were all like this. Let me show you properly with a couple of bones. So the bones were sticking out, oops, of the, oh, come on. Yeah, you have to Ctrl Z a lot. There you go. They were sticking out in this way, all of them, also the lower part of the leg, which was okay till I had to use some functionalities or advanced functionalities in Blender, namely the eye key constraint. The eye key constraints in Blender works properly only if the bones are all connected to each other, like this. So the tail is connected to the head of the next bone, or the child bone. And there you go. So let me get back to our animation. So this is our animation beforehand. We have this character which is moving in sort of unnaturally. Like you see that the movement is realistic, but is not really doing. I mean, it's kind of sliding on the floor. This is something that we don't want. So we have to. We will use the Bodynodes animation tab. If you don't know what I'm really talking about here, please refer to one of the videos that I already did. It was on how and why we have these two tabs around and what do they have, the concepts behind them. So we want the Bodynodes animation tab, which contains all the functionalities to animate a character, and we want to load the proper configuration file, or just the bones that we want to work on. In this case, we want to select the player, the blue guy, which is exactly this one. And here's our functionality, the one that we want to talk about, we are talking about right now. So let me select one of the bones. That's how it works. You have to select a reference point, a reference foot. In fact, it's called steady fit ref, and apply steady fit algorithm using as reference the selected foot. It's important that it's a foot for now. Might be an extension of functionality, but it's not really available, or we haven't done it yet. Okay, so something happened. You can see that the character kind of moved on the left, but what happened? Let's look at the animation. Let me run it again. And let me show how it was before. If he's letting me. So this was before. This is applying the steady fit algorithm. So what happened is that, as you can see, the animation is much better, meaning that now all the body is moving in such a way that the feet are anchored in there. They're not moving. So there you go. That's what this functionality is about. And probably if you're not really interested in what is the details, what is happening here, you can stop to watch the video now, because on the next stage of the video I will actually talk about on how I coded it in the details. So I really like to explain what I did in there, because you know, we are developers, we like to do cool stuff, apply different concepts, and then you know, get some kind of cool results as this one. And once we found the solutions of our problems, we tend to, you know, say to the world, look what I've done, something like this. But also I would like to spread and make my code a little bit simpler, so new people can join the project if they want. So what is happening here, that this is the function that is being called in the end. I'm not going to the details on how Blender deals with the code. Just know that it uses Python code to represent both the both functionalities and also the UI. So we don't care about how I set up the UI. What we care is the function that it's being called here, which is apply steady fit algorithm. That's actually what is happening when I play that button. We don't care how what has been triggered. What we care is that we just, in the end, I call this function. So first of all, I need a reference to the player I selected in the animation tab, which is coming from here. So it's blue guy because I just selected here. Then I need a reference foot, which will be the bone that I selected. So in this case, ref foot will be to R. And I really want it to be the foot, a foot. Please select one of the feet. If you have selected, I don't know, the head or any other bone, the functionality won't do anything. And right now I don't really know how to make pop-ups come out, so I still haven't, but it will print something in the console, which I expect you to know, because you know, to properly run these scripts, you probably need some basic concept of what is the console, which is this one, and how to run the script. Maybe in the future I will improve it more, but right now you need something in there. Then once I have my selected bone, I apply the ref walk algorithm with this new boolean that I added as true. So if you don't know what this algorithm does, please, and you are very interested in the details, please look at the previous videos that I've done. I really go into the details about the walking algorithm. But to make it shortly, I basically, what it does is basically, once you set a bone, and for the apply ref algorithm it can be any bone, once you select it, it will make the hip or the root bone of the character. The root bone of the character is the root, and around which all the other bones will move around. So that's why at the beginning you saw in the animation that everything was moving, this was still and everything was moving around it, because if you don't move it, it will stay there for sure. While the other bones, you might not move it, but if you move the hip, they will move with the hip. In this case, as I just said, the root bone is actually called hip, so this is the hip. It will stay there. So select the bone, in our case a foot, and what we want to do, we want to make the body move as this foot. And you would say, okay, so that should work, right? Unfortunately, it doesn't, because we have problems with the other leg. And in fact, that's what all this other part of the code does. This other part of the code will apply a couple of constraints on the other leg in such a way that the end result will be this foot to stick in there and not moving. And we'll go through step by step how I do that. But just notice, up to here, the right leg, it's fine, is moving as expected, because the hip, or the main part of the body, or the root bone of the armature, is moving to counter the move of the foot. But since it refers the movement of the hip will refer to one of the feet, the other foot will just move somewhere. totally unexpected, and the animation would still not be realistic. So what we do here first is getting a bunch of references that we need for later. So if I selected the red foot, I want the reference to the other part of the legs, so that I don't have to call all this function or to have this stuff around. If I selected the left part of the foot, the else will be, if not the right, it must be the L, left of the, or if I selected the left foot, I want the references of the right leg on the other, and here is the keyword is other foot, other lower leg, upper leg. Now this is foot dash or underscore, and because it's the foot has actually 2 bones, but you know, we don't really, I mean, it is basically the foot. So once I have the reference to the other leg, the first thing that I want to do is to remove as many, all the animation data that is actually giving me the problem. And thinking about it, the bones that are actually giving me the problem here are the lower part of the leg, meaning that starting from the beginning, we selected as reference foot, right foot, the other leg will be all this other part, be upper leg left, lower leg left, foot L and toe L, in this case. So I want to work on these bones, but in reality, actually upper leg is not giving me any sort of problems. It can, and actually I don't care if it moves left and right. And actually it's much better if it stays there. The animation data of the upper leg left bone stays there, because it will give some sort of better movement of the leg. It will still keep some sort of realistic movement. So in fact, I will remove animation data from these 3 bones, toe, foot and lower leg. Now this realization that the upper leg left animation data can still be there comes actually as an aftermath. I applied some few algorithms, and that I noticed, okay, actually I can keep this animation data. Why I don't need to remove it? It's much better if it stays there. That's what I'm doing here. So I just remove animation data that I don't want to have around, which is gonna complicate stuff, but I want to keep the one that is gonna be helpful. Then after that, well, I will work on the foot itself, and that's what this part does. I will create a temporary empty object in the same position of the other foot, and well, that's what this part does. Okay, yeah, in fact that's I create it, and then I set the location as the bone of the other foot. Let me show you where it will be. It will be placed in here on the head of this bone, and I call temp1 because I don't really care. I will just remove it later. I want to have a name that no one will ever use, so it doesn't interfere. This part of the code doesn't do much except selecting the proper object. It's not easy to because to create an object you have to go in object mode, but then all the other parts and of the code has to work in the pose mode, and that's what this part do. That's what this part does. Now once I have this object created in the same position by coincidence, or because I want it to be in the same position of the foot, it has no dependencies, it has no animation data, it just stays there. Let me show it to you. Okay, once I create it there, it would stay there, no dependency, so it won't move for no reason. It would stay there. I want this bone to be anchored anchored there. I don't want it to move too. So I will create a location constraint on the foot, and it will be constrained to the object that I just created, meaning that the object will stay in that position. I don't want this one to move. Now, last thing that you have to notice that if you remember in the initial animation, this bone actually moves, right? So how in the initial animation that I showed to you, the one with the problems, both of the feet were moving. So which location is the object gonna be? So if you look in the code, when I said that I'm gonna remove the animation, I remove all the points of the keyframe points except for the first one. So I start from start +1, meaning that if my timeline frames will be from 1200 to 1300, and I have all these animation points in 1200, what is gonna happen is that the lower leg, or the leg, will have just one animation point actually, and it will be the animation point at the beginning. So in fact, if I don't want an object to move, I don't want it to move from a specific position. In this case, the position is the position at the beginning of the animation. Now, so we understood why am I creating an object, why I'm applying the constraint, and where is this location, what location has been the bone constraint to, which is in the end the same position it was at the beginning of the animation. I want it to move. I don't want it to move at all. So we understood that up to this point, but then there is another problem that we have to solve. So if we were to stop here, what we would see is this. So what we would see is that this leg would be fine, the right leg would be fine, as I said at the beginning, the hip would move with the leg, so perfect. We will have a upper leg left which moves and is still okay, no problem. We would have this bone, the foot, stuck in there, not moving. But what is gonna happen with this bone, the lower leg left? Well, since we have removed animation data from it, it would just stick in the same position all the time. Meaning that if all these bones move up to the upper leg move, and we have this one, the foot not moving, what is the lower leg gonna follow in the end? The lower leg in the end is gonna follow his parent, the upper leg. It doesn't care about what his child is doing. Now, if the child is gonna stick there, still doesn't care. What we would see, and I can show it to you actually some sort of way, is this bone, or actually it's gonna I would see the leg or the foot actually be distorted in this way. Now, right now I'm moving the foot, Imagine in this algorithm is actually all the opposite. Everything is moving except the food. So the result would be more or less the same, right? And that's not what I want. I want actually this foot to stick there. I want the upper leg to move. What I want the lower leg, or this bone to follow the lower leg somehow, not the foot somehow. How do we do that? And that's where the I key constraint come very handy. Now, if you don't know what is the I key constraint, I can give it a summary, but it's much better if you look into it a little bit on YouTube or some tutorials. They're much better than me, and some of them are really intuitive. What I'm gonna say here is that the I key constraint, I'm gonna show something here. That's how more or less I do it. You need to add a bone constraint to a specific constraint, a specific bone. The target has to be something. Okay, so since we want to target a bone inside an armature, we have to select the object that has the armature, so blue guy, and then I want to, in this case, select to L. Now what is going to happen here? Look at this. You see? Now as you can see, what is happening here is that I'm moving the child of the bone as I want, and all the, in this case, all the armature will kind of move in such a way that all the bones will be connected to each other, and the movement will make sort of it works. Okay, now sometimes the animation can come a little bit weird, in very weird position. There are actually multiple solutions for a bone to be, let's consider this case. The bones have this position, but in reality I could rotate them, or I can move them around, or instead of being like this, they could be in this other way. So there is some sort of decision making in Blender or in the algorithm to choose which solution to take. And that's why we kept also this upper leg information in there, because so that we can set a little bit this IK constraint in a much better direction. We kind of restrict the solution that he will propose with the IK constraint. So let me remove it, and that's what this part do. This part of the script actually does exactly what I showed you before here in an add bone constraint. That's how I created. And well, we are here. Okay, now up to here, what we would see if we were to put a return statement here, what we would see is the script would just work already. We wouldn't need to change anything else. We'd see exactly the same animation that you'd see here. Exactly. But the problem, if I were to leave things here, so if I return statement here, what we would see is a character with constraints on some of the bones, which, okay, they make them do what I want, but I mean, it makes it hard to change things around. So that's what we are gonna do. We are gonna bake the animation. It's another functionality that I actually explained in the previous video, the video about the two tabs, Bodynodes recording and Bodynodes animation. But the bake basically takes all the constraints applied to a bone, removes the constraints but keeps the animation and sets all the keyframes exactly as the constraint was setting it to the bone, keeping the same animation in the word space and converts it in local space. But that's what this bake animation functionality does. That's what it's a function inside the script, so I made it, but it basically calls a function inside Blender in a particular way so that we just get what we need to do. And well, we are at the end. What we are presented with at the end is basically a body part, or we have our animation, all the bones have animation stuff. What we'd see though is that we have a new object around that I created here, the empty object, the sphere empty object, which will be here or anchored to a specific location, but it's sort of useless because I did it just to be used by our algorithm / functionality, so I just remove it. But first I have to set object mode, then I have to remove it, and then I go back to pose mode. But that's how Blender works. And well, that's it. So let's get back very fast to the algorithm. First I check what is the reference foot that we selected, then we try to make it work, but it won't work because the animation by itself will consider it's steady, so any changes, any location changes of the feet will be all around the same place. Okay, so that's the animation that we want to work on. So we can apply this work algorithm. We want the improved version, meaning that we want 3D full let's say movement of the body, so not only in the 2xy plane, but we want also on the z plane, so you can go up and down. We just apply it, and what happens is that the right foot is fine because it will stick there, but the hip will move around. We have problem on the left foot, so let's work on there. We get all the reference parts, we just remove all animation data that we don't need. We constrain the foot